What is the BGA of PC board? What is BGA, ball grid array? Ball grid array, BGA, is used in integrated circuits for circuit mount packaging. Ball grid arrays are used when we need to mount the devices permanently, such as many processors. The connections are made on the bottom of the SMD ball grid arrays. A solder ball is present on every single pin. A uniform circuit for the grid is also made on the circuit for better connection. The size of this grid varies from 1.27 mm to 1 mm. Although there are hundreds and thousands of component connections present on each layer, the number of routable pins per layer is limited. The via and the routed connection should be applied to the inner pion of the layer, as this technique is known as DogBone. There is another technique known as via in pad, which is used when the circuit needs the pads in the solder masking and the pitch of the circuit is relatively small. Ball grid array is recommended because it provides more interconnection pins. The solder ball is also provided with every pin. These pins can be put in flat, dual, and inline packages. The distribution of connection on the even and uniform circuit is compulsory. The bottom perimeter is also used sometimes, but the whole button surface is more preferred. The process of the ball grid array is critical and needs to be done carefully while following the instructions. Soldering in a ball grid array is done in an automated process and needs complete control over the process. That's the reason the ball grid array is not recommended for socket mounting. The thing that needs to be noticed in the ball grid array is there is no direct lead that connects the ball grid with the circuit. Instead of leads, the ball grid uses solder balls to make a connection with the circuit and to pass the electric current. There is a physical connection made between the substrate and these balls during the SMT assembly process. The physical structure is connected to the substrate by a wire which is responsible for the flow of the current. The conductive traces present in the trace are responsible for sending electric signals. This flow happens between the bonds and the substrate and the base of the balls. There is a term known as ball grid reballing. This technique allows the reusability of the component. That's the reason it is most recommended. The scrapping rate is low in reballing. This process is cost-effective and time-friendly because the ball grid package can be removed. This also saves the material of the entire process. In fact, the cost can be decreased in a high ratio if one selects to reuse on a ball grid array. Why choose a ball grid array for PCB? Ball grid arrays are used in printed circuit board packaging because of less density and low cost. Undersized chips are used for the interconnection of the circuit. On the other hand, there is another chip known as a conventional chip in contrast, which uses the perimeter section for the interconnection. The printed circuit board has relatively high performance and more space for connection. Moreover, the thermal resistance of the printed circuit board is low. It offers high performance at high speed. Printed circuit boards made from this technique are more reliable. Types of ball grid array. There are 3 types of ball grid arrays. These types are mentioned below: ceramic ball grid array, CBGA, plastic ball grid array, PBGA, tape ball grid array, TBGA. Each type is crucial in the processing and making connections, and each part has its detriments. The selection of the right solder is important for better performance. That's why relative types should be chosen for certain work. Let's understand the functionality of each type in detail. Ceramic ball grid array, CBGA. This ceramic package is used when the substrate used is of ceramic type. There are many further types of packages that come under the umbrella of ceramic grid arrays. For example, CCFA and LGA. The ceramic material is used when the temperature rate is high, as the base material is ceramic. These types of chips are used in computer mini processors. Multiple layer packages are used in this type. The flip chip method is preferred over the wire bond for the interconnection of the die. The reliability of the ceramic grid is increased by adding 90% lead with tin in 10% quantity. The difference in thermal coefficient of expansion in the substrate is also controlled by using this method. The packaging density and heat dissipation is high in this type. But the manufacturers have to compromise over the thermal compatibility, as it is quite low for a printed circuit board. Moreover, the ceramic process makes the cost higher. So, this is not a cost-friendly type. Plastic ball grid array, PBGA. As clear from the name, the base material for the body package is plastic in this type of ball grid. It offers high density and solves the cost issues by combining the overmolded pot array carrier and glob to pad array carrier. 63% of tin and 30% of eutectic tin is combined in the solder balls. The substrate is made in the sense that it can deal with at least 150 degrees Celsius of temperature. The size of the normal package of the plastic grid is almost 17/17. 0.8 mm to 1 mm is the ball pitch, so the average range of the ball count would be from 206 to 976 balls. Plastic grid arrays are sensitive to humidity, but they perform better in the case of electricity. The thermal compatibility in plastic balls arrays is excellent, which is a good choice for a printed circuit board. Tape ball grid array, TBGA. Tape ball grid array is used for a thinner base purpose. The electrical and thermal performance is optimal in the tape grid, while the version of the ball grid is relatively thinner. The wire bond and flip chip technology are used for facing up and face down wire bonds respectively. This increases the dissipation of heat. The printed circuit boards are reliable, flexible, having more space and fine lines in this type of all grids. Tape ball grid arrays are also very sensitive to humidity. They are less dependent, and the overall cost of the connection is also low as compared to other types. For having great manufacturing of printed circuit boards, the designer should have enough knowledge about ball grid arrays. Because the internal structure will depend on the design and correct use of the ball grid surface. Benefits of ball grid array. Following are the core benefits of the ball grid array. Ball grid arrays are a new technology used for interconnection in the circuit. This is done by using tiny spheres instead of conventional pins. So, this increases the benefits of the BGA in printed circuit boards. By ball grid array, the space of the printed circuit board can be managed properly. This package involves a smaller number of components and footprints. The space for the custom printed board can be increased, and this will enhance the efficiency of the circuit board. The ball grid arrays improve the profitability of the circuit in the manufacturing process. These packages are kept on a large surface, so the soldering of the large area is easier. The manufacturing yield will enhance, and then this will enhance the performance of the printed circuit board. The rework process is easy when the manufacturing is done in a large area. Ball grid arrays improve the thermal and electric conductance of the circuit. As the circuit is of small size, so the heat can be dissipated easily. But the most heat can be transmitted on the board when the silicon wafer is present on the top surface. In other cases, the silicon wafer can be connected on the bottom side, then the other side of the silicon wafer will perform the role of best available space for heat dissipation. There is less damage in the circuit if the ball grid array is present because of the use of soldering balls. The soldering technician will be at ease when dealing with the ball grid array because it aligns itself on board along with stencils. The interconnection between the die and the pad is low, and this improves the electrical conductance. The connection present on the bottom of the chips is shorter and assures the speed and performance of the circuit board. The pins used in the process are fragile and very thin in size. This increases the ratio of damage. And we already discussed that this damage is nearly impossible to overcome. But the ball grid array connection makes sure that the process is reliable and there is no chance of damage and break. As a result, the connection is more reliable. The overall cost of the connection will be reduced. All the benefits mentioned above will help in decreasing the cost of the process. The defect rate will also be reduced, and the material and resources for the connection can be saved. Interested in knowing more about design and PCB assembly? PNC is providing complete 24/7 support to execute the design at affordable rates. Just write us at sales@pnconline.com.